Welcome everyone. My name is Chris Brousseau. We're here to talk about Pandas and Polars and all this good stuff. I appreciate you coming out to see me. Let me see if this is gonna work here. Hopefully I don't have to do it manually. There we go. All right, great. We're going to talk about a lot of stuff today, but if you walk out of here, there's kind of four important things. First, like Pandas, we use it because it's stable, because it's powerful, covers a lot of stuff. Polars, new kid on the block, it's super fast, maybe a little bit unstable on the API, but these two things work great together. Both of these libraries are getting faster, and Arrow is a big engine behind a lot of that. So the one takeaway for everybody is like, let's find ways to munge these things together to make our pipelines better in smart ways. I missed a slide here. I don't know why it's hiding. A little bit about me. He just went through. Let's talk about Apache Arrow and really what it is. So Apache Arrow is this in-memory format for tabular data. It's very much like just the memory equivalent of Parquet, which is a columnar format for data on a disk, right? And if you ever loaded a CSV, it's slow. Load a Parquet, it's fast. Arrow brings like three super important things for us. First, this idea of interoperability, the ability to kind of move the access to data, not the data itself, between programs. Arrow helps a lot with that. Secondly, it's tackled a lot of the data type problems that we've struggled with over the years. NumPy is awesome, but the name says it all. It's focused on floats and numbers, etc. So data types, it's got great coverage for strings and really great support for missing data in all data types. And that is super important in pipelines and super important in data science. And lastly, it brings a kind of a new paradigm of speed to data analytics and processing, and it does that really in kind of two ways. These graphics aren't mine. I borrowed them from the Apache Foundation. The first way it does this great speed up is by applying a memory structure that's based on columnar data. So looking at this red, green, and blue data structure, when data is coming in, it's going to put stuff in a certain column in a block and locate that in one contiguous memory area and do the same with others. And that is helpful because when you're looking for data, you really just want to get the data you want. You don't want to go get everything and throw it out. And columnar data is the way that very fast databases like Snowflake and other MPPs like Redshift work. They kind of segment things like this. So Arrow does this for us in memory, so we can be faster by just getting the data we need. The other thing that's very cool is this idea of zero copy. So when we're transferring data between programs, instead of copying data from program A to program B, we're really just going to get some pointers and some metadata. If both of those things are backed by PyArrow, pass those things over. So you're really just transferring a teeny amount. The data's staying in the same place in memory, and poof, you have access to it. And that's really the magic of it, right? So there's some more links here to kind of check out. And apologies in advance, this is a 15-minute talk, so we're gonna be a little bit speedy. All right. This microphone popped off. Some key differences. I'm not going to read through all this, but the takeaway is Pandas has been around for a long time. It's actually probably one of the reasons Python's so popular in the data science and machine learning space, because of the access this gave to data in the universe of researchers and things like that. But it was built for flexibility and completeness. So the API has a lot of stuff it can do. There's a lot of different ways to do the same thing. Sometimes that's confusing and hard to work with, but it's still very powerful and the building block. Polars, new kid on the block, brings to the table a lot of the thinking about access to data that we've learned from, frankly, databases, right? Only materialize what you need and think about those kind of concepts. And its goal is to be the fastest data brain, period. Right? It's not going to try to cover everything, it's just going to be fast. Some differences in memory. Pandas based in NumPy forever. NumPy's still there, that is the default, but Arrow this year in particular has kind of come out to the forefront. It is still optional, but in the future, it's going to be required. So Pandas is moving to Arrow as the back end. Polars already started there. They all have these wrappers and stuff, but the future's clearly Arrow. By the way, these two libraries, not the only ones that use Arrow. Spark, some of these others, I heard Databricks mentioned in an earlier talk, all of those have kind of flavors of Arrow around. The other thing that's interesting in memory is that Pandas is built around the idea of working with just kind of the memory you have, Polars recognizes there's a big need to work with data that's larger than RAM, or what we call out of core. So it's got some built-in support for cool stuff around kind of chunking and paging and some spilling to disk. It is slower, but it is built to, from the beginning, to work with. Whereas with Pandas, especially with intermediate folks, you have to kind of wire that up yourself, and sometimes that's a little bit tricky. The APIs, very similar in a couple of respects, except for maybe scope. You know, I've mentioned this a few times. Pandas is much broader. Polars is not one for one, but all the core stuff is there, right? The reading and selecting, merging, those kind of things are there. It's different in the sense that Pandas lives for the index. We do a lot of things in data science where we're indexing data and selecting on those and doing group bys around the index and those kind of things. Polars does not have an index. And so there's a little bit of a mental model. It's more like SQL-y. It's more database-y, if you can kind of think of it like that. We'll look at some syntax examples in a little bit. The other thing that's very interesting here, beside the multi-threading, I didn't highlight it, is this idea of an API mode that is eager and lazy. So Pandas is all eager, so you click run on your cell or your Python script, and it's just going to go get everything and gobble it up. Polars has that. It also has what's called a lazy API, where for some operations like reading and selecting and merging and these kind of things, it's going to first look at your query if you've said do this lazily. It's going to look at the data and look at what its rules are and kind of figure out, hey, is there a faster way to do this stuff? You know, maybe you're doing a select on some categorical data at the very end of your thing. It might say, well, let's just move that up to the top so we select a lot less data. You know, things like that that are hard to keep track of. That's super powerful. Polars also multi-threaded, right? And so that's great. You get some parallelism out of that for a lot of operations out of the box. You can do a lot of these things with Pandas with other libraries as well, but the scope of this talk is really just what's there. Recently, and I'm talking about this year, super important stuff, Pandas has had these big developments around moving to PyArrow. And I know that early in the year, there's a lot of maybe rough edges around that. You'll see some videos like, don't use PyArrow, it's not really ready. I think some of those have really been smoothed over just over the summer, right? We're on release 2.1.1, and it's faster in many, many use cases, but your mileage may vary. So part of what you're gonna see here is a repo that you can download and run on your own for some simple reading activities and just see how's it work for me in my case. The other thing that is interesting about this summer that I'm a highlight, not a priority for the talk, is this idea of copy on write that simplifies the API. It's very important, but I don't have time to go into it now, so hit me up afterwards if you're interested. That helps with speed, but also maybe reliability. How much faster is all this stuff? You're going to see 1,000 benchmarks. They all vary. These are the benchmarks from my laptop yesterday, okay? Reading CSVs and zip files, lots of us are getting into these files, 3 to 20x speed up. I'll show you why the range is so big in just a second, because I realize maybe that's not so useful, but it is important to highlight that there is definitely improvement. The other things to think about are that there are some considerations. Polars is new, it's like .19, so the community is smaller, but it's definitely growing, and the docs are great, love it. I would say that their API maybe changes a lot, so you know, Pandas, you can pretty much depend on the APIs going to change very, very slowly over time. That's a design principle. So let's look at some of these benchmarks in a little bit more granularity. This chart, you can repeat your own when you get the repo on your own. The takeaways are not what are all the bars and what are the numbers. The takeaways are most of the bars on the left are different ways Pandas can read a zipped CSV or something like that. And there's a lot of ways to configure it. So when you're doing your benchmarking and you're looking at your own setup, the very first thing to look at is like, what am I doing? And am I actually doing like the best thing with Pandas today, or is there a simple one-liner or some other thing I can use, like change the reading engine or something else with a different API that can get you some big speed ups? Because this isn't obvious when you're looking at the docs, that there's a huge performance difference. The other thing is that there are big performance improvements with Pandas and Polars. So if you look at the yellow bar on the left, that's like the native Pandas, read it into NumPy. Some 3 gig file takes a minute, at least on this machine. With PyArrow as the engine and PyArrow D types, it's like 5 seconds, 6 seconds, something like that, a lot faster. Now, Polars out of the box is 3, so it's still faster, still good. Again, your mileage may vary based on how many cores in the CPU and all that kind of stuff. But walking away from that chart, let's get the best out of pandas to start with. There's a few simple things you can do. These are much more reliable this year. Again, please let's talk about copy on write later because that's going to be important. And let's talk about some syntax differences with these libraries. It's pretty simple. These cells are all raw cells. You can run them when you get the repo later, but you can see like reading stuff, it's exactly the same, okay? Maybe doing a select, it's a little bit different. It gets a little bit more complicated when you get into kind of like real queries and stuff like that, but it's manageable. There's like, you know, no mixing of square and regular parentheses in polars. It's a lot just sort of simpler that way. Syntax differences are interesting. The other thing that's interesting is to hammer home this idea of what makes this stuff fast. A lot of it is PyArrow. Yes, there's multiprocessing and Rust and polars, but columnar is really what's driving a lot of this. This is an example, and I'm sorry if you can't read this, but this is an example of loading into Pandas a Parquet file. Single-threaded, takes 86 seconds, okay? By using the predicate pushdown through polars and PyArrow, I'm only going to read the slices of data I want. Right away, I can reduce that to 10 seconds. So when I'm talking about material things we can do by being smart about how we're reading things in, this is one way to do it. The next way will be to think about how could we pull polars in to complement our library. And there's a few big ways. I mean, first off, we can drop this thing in the front of the pipeline and reading things faster. We can relook at some of the expensive operations we're doing. It's not just selecting, merges are expensive, grouping, you know, those kind of things can cost a lot, and you can find ways to carve out a slice of your pipeline, put it into polars, and then pass it back if you need to. You don't necessarily have to re-engineer the whole thing, right? You can do it smartly if you kind of, again, look at the kind of data you're working with, et cetera. There are some limitations. The data does need to be kind of, I would say, polars friendly. There's a lot of flat file formats in Pandas data frames. It's super easy to get stuff in and out. A lot of standard databases has SQL support. I mentioned Databricks earlier, but there are some things that it's not super workable. I just built this project. We worked on it for about 8 months. We were building some recommender systems through a pipeline that started in S3, and polars was really helpful there because there's thousands of files. We're reading them in all the time and munging that stuff. Polars was helpful for that. When we moved to a Snowflake share, less helpful because we needed the Snowflake library that had auth and paging and just all these other things that were necessary. They only had a Pandas API, but once we got it into Pandas, then we could plug polars in as needed later in the pipeline. So you got to kind of look at what you're doing. How do you do this? It's literally this simple, to from polars. That's it. A little bit of configuration, but it's not too crazy. How does it really work in practice? Here's a quick example. Again, you can convert this to code and run it. So we load up this polars data frame that's from a Parquet file, and we transfer it to Pandas. Takes 65.81 seconds. That doesn't sound like super fast. Not impressive. But that's Pandas using a NumPy backend, right? If I switch to a different data frame using a PyArrow backend, it's 2-point-something seconds. So it's a 28x speed up. So if something's going to cost me that much to transfer, this isn't the whole data frame, this is probably 600 megabytes or something like that, 2 seconds, I can do that a bunch during a pipeline to pass things back and forth. So I can kind of surgically find places where I'm going to get a big improvement and plug it in and not have to rewrite everything. So that's good. That's good for me. So the TLDR is, again, Pandas is really powerful. We use it for lots of reasons. It's stable, flexible. You can do things lots of different ways. Polars is definitely fast. They're both powered by PyArrow. PyArrow helps us connect into this universe a lot more easily, so I'm a big fan. That's all I had for today's talk. Thank you very much for listening. I also like to thank my reviewers for listening. Here's my contact info, a repo link, and also the QR code will bring you to the repo. Feedback, constructive feedback, super welcome. I'm sure we can make it better, but take a look at this and see how it works maybe in your environment. And thank you so much for your time. Oh, before we bounce, I do have. I forgot something. I do have a small gift here. Effective Pandas by Matt Harrison book giveaway. Is anyone here at PyBay for the first time? You're first. Yeah. For those of you who don't know Matt, he's spoken here before. He's really a great writer, does a lot of training, and the book has got some good ideas, so take a look at it. Do we have time for a question or two, given our schedule? What?
We're asking if you can ask your questions to him offline.
Okay.
So
Sure.
if you catch him out there, please ask the questions.
I'll just be outside. If anybody wants to chat for a few minutes, I'd love to.